Hi everyone and welcome to our mathematics form 4 logical reasoning. Okay, this chapter is quite not hard, but all the things that you learn today you're not involving in calculation, or in just a sentence or in words. So no numbers, no calculation inside. You just can throw calculator away and learn this one. Now we say about logic. Logic. So if we have a logic, they have a statement. A statement is a sentence of which the true value can be determined. That is either true or false, but not both lah. So simple words. Statement equals to sentence. The sentence can be determine the true value, either true, false, either is correct or not. And the sentence cannot be question mark, exclamation mark, or an order. For example, KL Tower is the tallest tower in Malaysia. This is a statement. Whether it's true or false is a statement only. And also mathematics also can be a statement. 1 plus 1 equals to 2 is a statement. -3 larger than -9 is a statement. But m plus 2 equals to 3, that is not a statement because I cannot determine the value. I can't determine the true value. I do know this statement is correct or not. So that is not a statement. How do you come to school? It's not a statement because the question mark. Because you didn't give me the answer. And I cannot read your words to determine the true value. So not all the mathematical statements are true. The true values of the mathematical statements can be determined. Today we say statements have true or false. But today I can make the false statement to true statement and making the true statement to false statement by using negation. I can negate a statement using the words not or nor to negate a statement. The negation of statement P is just like this. For example, let's say 12 is a multiple of 5. This is a false statement. But today, I negate it to become 12 is not a multiple of 5. Then this is a true statement because I'm doing the negation. Become the true statement. The true values change from true to false or vice versa through the process of negations. And also, if I say that negation equals, negate already become not equal. If larger than or smaller than, larger than, if I negate is smaller and equal to, because we negate and the not equal also we negate become equal. So remember this one. This is the things you need to know. And we can using this one to determine the true value. Now we can talk about one statement. Not just one statement, we can also have two statements. We can let two statements combine together using this one. A common statement is a combination of two or more statements by using the word and or. One statement and another statement, whether it's same characteristics or not, the two statements can be combined together using and or. For example, a pentagon has 2 diagonals, a heptagon has 4 diagonals. I want to make these two statements become one statement. So P and Q, a comma statement. So a pentagon has 2 diagonals and a heptagon has 4 diagonals. We can using the compound statement to determine the true value, the determine the true value for the statements. Okay, this is a table. Okay, this table seems very hard to remember, but actually we have one way to remember it. Okay, if one of the statement is false, P and Q will become false, but P or Q become true. If all the statement is true, always true. All the statements are false, always false. Okay, make it in a simple words. Okay, if one of the statement is correct, but another statement is wrong, for P and Q, two statements must be correct. If one of the statements is not correct, it becomes false. P or Q, we can choose one of the statement. Okay, whether it's wrong or true, one of the statement is true, then true. One of the statements is wrong, true. Sorry. But if two statements wrong, automatically false. Okay, two statements correct, all is true. Two statements wrong, all statements is false. Okay, you only combine two statements, also can break the compound statement, become like this. Okay, we can also pecahkan construct statement in the form of implication. We can using the implication if P then Q. P is denoted as antecedent, Q is denoted as the consequence. For example, I have an antecedent x equals to 1. If x equals to 1, then I have a consequence. X plus 2 is 3. If I eat my lunch today, then I need to eat my dinner at night. If I sleep well, if I sleep early, then I can wake up early. That is the statement in form of the implication. And also we can break and make it together, become like this. P if and only if Q. It means these two statements can be combined together, also can break out, become two statements, two different statements. Okay, if P then Q, if Q then P. Okay, for example, x equals to 2 if and only if y equals to x plus 2. Okay, I can break it up, become if x equals to 2, then y equals to x plus 2. And my second implication, I just switch my position on it. If y equals to x plus 2, then x equals to 2. Okay, this kind of switch process, we can make a new things. Okay, that is called ICIC. Oh, what is ICIC? We see this one. Okay, we can construct and compare the true value of the ICIC of an implication. Okay, today we say about P then PQ is a statement. If P then Q is a statement, we can switch the position. It become the converse. Inverse means I negate the statement. Contrapositive, I switch the place and I negate it. And we can remember these four things by using the method. If I see means the ballet, I see the ballet. Okay, set alphabet is negate. I C. Here is negate. C here is negate. But IC is the ballet. Means to the ballet. But this is only for DLP students lah. For non-DLP, very sorry to say, because I don't have any idea to do it. But if you have the ways to remember it, okay, you can use your own way. This is just one of the suggestion on it. Okay. Yes, so bahasa Melayu. And we can using these four conditions to determine the true value. This table, wow, seems very hard to remember it, but actually like this. If two statements are true or false, two statement is true or false. Okay, every condition must be true. If one of the statement is false, what happened? P is true, Q is false, then the next two will be rotate. You rotate become false true and true false. Here is false true, here must be true false, like this lah. You just need to know S is IC, this one. IC. Always remember this one, so you'll be not confused. But these two is very easy. Just these two rows is very hard to remember, but you can detect the same pattern here. Okay, this is for the bottom layer. Okay, and today we can determine and counter example to negate the truth of the particular statement. This part of the topic, okay, like this topic lah. Okay, I say it's like not everyone know about this topic, but when I do a research, okay, I realize the counter examples is means like, okay, this statement is wrong. I need to use an example to saying that the statement is false. Okay, for example, the sum of the interior angles of all polygons is 180 degrees. Okay, this statement is false. Then I need to use a counter example. Okay, to saying that the statement is false. False because the sum of interior angles of a pentagon is 514. Okay, 540. Except 180 punya shape lah. Okay, we can use 360, 720, 1080. Okay, also can. Okay, except for 180. Okay, now we end for the statement. We have statement, then we have argument. If someone states something, then I need some arguments. We have two arguments. One is deductive argument, one is inductive argument. Okay, deductive argument is general, okay, premise to specific conclusion. But if this one, inductive will be specific, okay, premise to general conclusion. Okay, you see, the first premise must be the general form, in general form. But if this one for IA different, okay, all the premise is specific, then my conclusion is in general. Okay, today I can using those arguments to determine the valid sound for the deductive argument. Okay, I can using the table and also the conclusion, okay, to determine the valid and the sound for the argument. Okay, not as argument, not statement again. Not as a argument. Okay, form 1, form 2, form 3 is detect the valid. Okay, the argument must follow the form. Okay, then we can say that is a valid. But if it's not valid, you automatically become not sound. Okay, that is the thing. And for form 1 is all A are B. A, B, and my previous two is another new thing. C is A, C is B. For form 2, I think very easy. Because you already know about F, P, and Q, then you can just say that P, Q. But both must be true lah. Okay, both must be true lah. But if they say both is not true, and then I need to switch their place, become QP. Okay, that's the thing. If one of the premise does not follow the form, then we can say that the argument is not valid and also not sound. Okay, for the sound, if the conclusion is true, there will be sound. If conclusion is false, then we can say that is not sound. Okay, for example, we can make the premise, okay, and conclusion become a valid argument, valid DA. But I didn't say about sound or not sound. They want just different thing. Okay. Okay. So, for example, all whole numbers are real numbers. All A are B. This is a form 1. Okay. C, this is a C1, that's a new thing. C is whole number, C is A. So I need to give answer. C is a real number, C is B. That is for the form a valid DA for a situation. How to determine, okay, for the inductive argument? For inductive argument, okay, we have only two things: strong, weak, cogent, and not cogent. Okay. For the weak, okay, for the inductive, we will determine the conclusion first. For the inductive, we determine the premise first, the valid. Okay, if one of the premise does not follow the form, then we can say not valid. But if the conclusion here for inductive conclusion is false, then automatically become weak and not cogent. Because your conclusion is false, then everyone cannot believe your arguments. Okay, if the conclusion is true, then you can say it's strong. It's a strong. If all the premises are true, then you can say a cogent, strong and cogent. But if all the premises are false, then you can say that is the not cogent. Okay. Actually, one of the premise false, also not cogent. Okay. This is the thing. And about the strong and weak, you know about one thing. Okay. I think you know about one trend. Okay. I say in Chinese lah, sorry, because this is the one shop called Nasi Lemak. Okay. I don't say the thing because the trend, you know. Okay. The advertisement. Okay. Got one sentence like this. Okay. 普通的给 weak man. Another one is what 辣的给 strong man, 普通的给 weak man. Then when I think this one strong and weak, then I will think about the nasi lemak. Okay. If you want to know what is the nasi lemak called, okay, can check IG. Okay, the nasi lemak, you know. You know about the trend, right? I think you know about it. So the nasi lemak, we have 3 levels. One is very big. For the ordinary. Okay. The second level is little bit spicy. For the third one is very spicy, and just because of very spicy, then you need just very spicy and very spicy. You need to fill the consent form. Okay, that consent form. Just because it's very spicy, then you need to fill in that consent form. That's the thing lah. Okay, and we can forming a strong inductive argument in a certain situation. You see, all this thing is in specific. I can conclude, okay, my argument in one sentence because I say about it is for the specific to general. Strong one must be strong one jangan boleh fake punya. Okay. So now we conclude our chapter. Okay. In this chapter, we learn about statement and arguments. Statement only true, false. We know about negation, how to make the statement negate it. And we have compound statement. We combine two statements together using or and. Implication we have two. If P get Q, we combine it become if and only if. Also we have converse, inverse, contrapositive. For argument we have two. For argument we have inductive argument and deductive argument. One is the strong and cogent. For inductive argument, you have valid and sound. Okay, valid is for the form. If the form is correct, is comply the form. Okay, that is valid. Sound if the conclusion are true. For strong and cogent, okay, if the conclusion is true, then you can say that that's a strong. Cogent means all the premises are true. So that's all from today. Okay, we will move for next chapter. And if you are interested in my one-to-one tuition, you are very welcome to contact my phone number. Okay, and that's all for today. Hope you have a nice day. Okay, we will see you in next chapter 4. Goodbye.